Electricity is all around us, from the electronics in your home to the transmission tower lines running across our landscape. Every aspect of our lives involves electricity. We've become dependent on it for our daily lives, yet it also can be considered one of the most dangerous things in our homes. My name is Daryl Marks, and this is Jeff Newbern, and we're both linemen at an electric distribution cooperative. Today we are going to talk to you about some common electrical scenarios. But before doing so, we want to point out the specialized PPE or personal protective equipment that Jeff is wearing, as well as what equipment is on the trailer behind me. Starting with Jeff's hard hat, it is not only protecting him from something hitting his head, but it's also dielectrically tested to help protect him in the event his head would come into contact with anything energized. We actually work on energized lines and equipment while in bucket trucks. His safety glasses protects his eyes from flying particles. Linemen also have to wear FR clothing. The clothing is treated to help prevent furthering an injury in an arc flash or a fire situation. The yellow rubber sleeves are to protect his arms in case he was to accidentally contact the energized lines and equipment. The gloves are to also protect him when he is handling the energized equipment. The gloves and the sleeves are tested against failure at 20,000 volts, but have a maximum working voltage of 17,000 volts. The gloves are covered with leather protectors, which look like normal gloves, but they're to protect the rubber from snags or tears. The yellow stick he's holding is called a hot stick. It is insulated and tested regularly against failure. Jeff uses it as an extension of his hands, and it enables him to do his work while staying farther away from the energized equipment. Everything you see on the trailer is the exact equipment you see while traveling up and down the road, with the exception of the poles are made shorter. The pole at the far end of the trailer with a light and meter base on it represent what you have at your home. You might also find a meter on a business or a storage building. There are wires that connect the meter to the transformer pole. The transformer is the gray cylinder hanging on the pole. This is a device that transforms the higher voltage of 7,200 volts that travel through the primary or top wire down to the secondary voltage of 12240 for a typical house, or a different voltage for some businesses. Above that transformer is a fuse. This is a safety device, much like the breakers or fuses that are in your home. Between the poles on the trailer are a top wire and a bottom wire. The top wire, or phase, is energized at 7,200 volts. The bottom wire is a neutral wire, which can also carry a current, but is also grounded. At each end of the top wire is a gray insulator that isolates the energized wire from the poles. On the center pole is a smaller gray cylinder that looks like a transformer, but it's actually a recloser. This is another type of safety device. Above the recloser is another fuse. The last pole has a large black wire on the side of it. This is another type of phase wire, but one that carries a 7,200 volts underground. You might see these at the entrance to subdivisions or large shopping centers. Next to that pole, at the front of the trailer, is the green box, which is another type of transformer, but this one is for underground facilities. These are also energized at 7,200 volts. You should always use caution around them and always call ahead for locates when doing any digging to avoid coming in contact with any buried power lines. We will now demonstrate to you what can cause the power to go off at your house, why a bird can sit on a power line without being electrocuted, to the dangers of a balloon or a kite making contact with power lines. There's one thing to keep in mind throughout this demonstration, is that electricity has one objective. This objective is to always find a path to ground. So you're sitting at home on a beautiful sunny day and your lights go out. We often associate a power outage with a thunder or a windstorm, but there really are many things that can actually cause an outage. One of these being animals that can access the equipment on a power pole. The transformers and reclosers mounted on the poles are connected to the neutral wire, which is the bottom wire between the poles. It's the wires that are connected to the bushings on the top of the transformers or reclosers that are energized. We now would like to introduce you to the third member of our team, Mr. Squirrel. When Mr. Squirrel makes contact with the energized wires in the equipment at the same time, it completes the path to ground and causes a ground fault. Mr. Squirrel made contact with the energized wire while standing on top of the transformer, which caused the fuse to blow. That is a loud bang you heard. The fuse energized or fed the line the transformer was on and did exactly what it was designed to do. And now as a result, you would now be without power. When you see a bird sitting on the wire, the bird is only touching one wire. That bird is at the same potential as the energized wire, and it's safe while only on this wire and not touching anything else to complete the path of that wire to ground. Jeff is now replacing the fuse. This is a necessary step in order to restore the power to your home and can take an extended period of time for the lineman to make it to the location of the fuse. Now that the fuse is replaced, you can see the light is back on. Now imagine you're sitting at home on the same sunny day and your power blinks off 1, 2, and 3 times and then goes out. This blinking is due to a recloser like the one on the center pole working as it should, but acts a little differently than a fuse when a ground fault occurs. This momentary interruption in power is designed to allow whatever caused the ground fault to clear itself. If the cause were to clear itself, the power would not completely go out. Instead of having a fuse in the center cutout, Jeff will close in the yellow handle on the side of the recloser. And notice a light on the meter pole is energized. Jeff will now use a ground cable to create a fault. The recloser is trying to allow the cause of the fault to clear itself. When the recloser does completely break the circuit, the handle on the side of the recloser will drop down. Even though the blinking of the lights may be inconvenient, it can eliminate an extended outage, and it also shows that our equipment is working correctly. Can wood be a conductor? Yes, in the right situation, wood can be a conductor. Now notice the light on the pole is lit, and also notice there's no fuse in the center cutout, and the handle on the side of the recloser is down. Now how is that possible? Well, there's a tree branch across the 2 wires on top of the recloser. This tree branch is conducting the electricity that is energizing the light. The important message here is that wood is a conductor, and it's also important not to climb or cut trees that are close to power lines for this reason. Using wooden or aluminum ladders around power lines is also not recommended. Another type of conductor is a kite string. Do you ever think about overhead power lines before flying a kite? Jeff has placed an ordinary kite string in the place of the fuse on the center pole. Notice the kite string is now conducting the electricity that's energizing the light. How many of you have ever let balloons go for fun? Have the balloons ever looked like the one that Jeff has at the end of his hot stick? This type of balloon is metallic coated and can cause a damage to electrical equipment if it were to come in contact with it. Jeff is now going to put the balloon in place of the same fuse. Do you see the sparks tracking around the balloon? That balloon is actually conducting electricity. Always be aware of your surroundings, as power lines can make the most ordinary action of releasing a balloon into something dangerous. Ladders can be useful, but placed in the wrong spot can turn a helpful situation into a harmful one. Now, we had mentioned earlier about not using wood or aluminum ladders around power lines. The service wires leading into some homes could look like the ones you saw between the meter and the transformer pole at the end of the trailer. Now imagine someone using a ladder to clean out the rain gutters on a house, and they happen to make contact with the service wires. Now watch what happens when Jeff takes the ladder and touches the energized wire. The ladder actually conducted electricity. Now, since the person carrying the ladder is grounded, much like the squirrel was on the transformer, the arc you saw shows the person completing that path to ground through the ladder. Do you know what to do if you are ever in a vehicle accident involving down power lines? Do you stay in or try to get out? Unless you are in some kind of immediate danger and/or if the vehicle is on fire, you want to stay in. If you have to get out of the vehicle, you want to jump free with both feet together and not touch the vehicle and the ground at the same time. Once free, shuffle or jump with both feet together a safe distance away from the vehicle. Are you wondering why you would need to shuffle or jump away from the vehicle? Pretend you just threw a rock into a puddle of water. The rings that rippled away from the rock would represent how electricity can dissipate out into the ground away from the vehicle. Depending on the type of soil and whether it would be wet or dry would determine how far the electricity would dissipate. If you were to take a step, there could be a difference in voltage from one imaginary ring to the next. This difference in dissipated voltage from one foot to the other or one ring to the other could cause electrocution. Now Jeff is going to use a metal pipe to demonstrate what would happen at your feet if you were not to jump clear of the vehicle and instead touch the ground and the vehicle at the same time. Your body would be conducting electricity and be completing the path to ground. The same would apply to anyone trying to help and run or walk up to the vehicle involved in the accident. If you are able and someone is wanting to approach the vehicle, yell at them to stay away and call 911 for help. For the past few minutes, we have shown you how squirrels, tree branches, balloons, kite strings, and ladders have conducted electricity. We have also mentioned ways the human body could be a conductor of electricity. This last part of the demonstration is an example of how the human body can be a conductor of electricity. A hot dog has the same makeup of the human body. It's made up of some meat, salt, and water. This makes the hot dog the best item to demonstrate what would occur if a human makes contact with electricity. Now watch as Jeff uses the hot dog to make contact with the energized phase. You will see a difference in the flash as well as the sound. That is proof that the body can and will conduct electricity. Don't become a hot dog and think that you're quicker or smarter than electricity looking for the path to ground. Thank you for watching the safety demonstration today, and always remember, electricity can be our friend, but when not respected, it can quickly turn into our enemy. Always be aware of your surroundings and keep yourself and others away from power lines.